Electrical contactor working principle. We use a contactor to turn on and off heavy and high voltage electrical devices such as motors, fans, pumps, etc. An electrical contactor is a type of electrical switch used to control a high power load or circuit, typically in industrial or commercial applications. It works based on the principle of electromagnetic attraction and mechanical switching. Here is how it works. Electromagnetic coil. The contactor has an electromagnetic coil that is connected to a control circuit. When a current flows through this coil, it creates a magnetic field around it. Main contacts. The contactor consists of a set of main contacts that are normally open. These contacts are responsible for carrying the current to the load. In their resting state, these contacts are not touching each other. Plunger assembly. The magnetic field generated by the coil attracts a plunger assembly, often made of iron or another ferromagnetic material. This plunger assembly is mechanically linked to the main contacts. Contact closure. When the electromagnetic coil is energized with current, the plunger assembly is pulled towards the coil due to the magnetic attraction. As the plunger moves, it brings the main contacts along with it, closing the circuit and allowing the current to flow to the load. Release mechanism. When the current through the coil is turned off, the magnetic field dissipates, and the spring-loaded mechanism in the contactor forces the plunger assembly and the main contacts back to their open position. This action breaks the circuit and stops the flow of current to the load. The electrical contactor's primary function is to provide a reliable and safe way to control high-power loads without exposing the operator to the high voltages and currents involved. It allows for remote or automated control of these loads and can also include additional features such as overload protection and auxiliary contacts for control and monitoring purposes. Keep in mind that the exact design and construction of contactors can vary, but the fundamental working principle involving electromagnetic attraction and mechanical switching remains consistent.